is a lesson on bases and polyprotic ions, or polyprotic acids. For bases, it's the same thing as with acids. Strong acids, strong bases are the same. Weak acids, weak bases are the same. Strong bases ionize completely. And the strong bases, remember, are group 1 and 2 hydroxides. Lithium hydroxide, calcium hydroxide, magnesium hydroxide. There's some debate on some of the group 2 hydroxides like magnesium and calcium. They're kind of iffy, but we gotta go draw a line someplace, and that's what we're going to do. So if you have 0.1 molar lithium hydroxide, that means you have 0.1 molar hydroxide, and pH, or POH, would equal to 1, and the pH would then equal to 13. So that's how you do with strong bases. Exactly the same, but remember, if you take the negative values of POH, not the pH. So if they're asking you for the pH, you gotta go that way. Many of the weak bases contain nitrogen, also known as amines, especially organic. You can also do like iron hydroxide, the transition metal hydroxides. Those will tend to form weak bases too. These things will form an equilibrium if your base B plus water, liquid, equilibrium, where the base is a proton acceptor, so it gains an H plus, and the water must be the conjugate acid, so it's going to lose an H plus and turn to OH minus. So that's where your OH minus comes from. KB, BH plus, right over left, hydroxide over the base, or using the assumption, and this is going to be more tricky than the acids. There are more borderline bases than acids, so be very careful on this. Kb is equal to x squared over the concentration of B. And again, that's only if you have one source. If you have two hydroxide sources, you gotta do just like we did with the acids. You might note here that X is equal to the hydroxide ion concentration. Again, this is why some people force you to write this first, so that you know X is not hydrogen ion or hydronium ion, it's hydroxide ion. Example, mathematical example. The concentration of CH3NH2 is equal to 0.6 molar. The Kb is 6 times 10 to the negative 5th. Find the pH. pH, careful. Shortcut, it's the only thing there that has less than 10 to the negative 4, so let's go with the shortcut. 6 times 10 to the negative 5 equals x squared over 0.6. Cross multiply. 3.6 times 10 to the negative 5 equals x squared, square root both sides. X equals 6 times 10 to the negative 3 molar hydroxide. You might even want to emphasize that. Take the negative log to get the POH, and 14 minus that will give you the pH. An interesting help here, Kw is equal to Ka times Kb, which is 1 times 10 to the negative 14. Sometimes they will give you the Ka, but you're interested in the conjugate base, so you gotta change. They won't give you the Kb. You gotta figure out what the Kb is from the Ka. So you use this if looking for the conjugate base, usually, sometimes acid. So if they give you the Ka, you'll need a Kb or Kb Newton or Ka. This happens, especially next unit. If you want to find out what it is, what the Ka is for CH3 NH3 plus, this is the conjugate base for this. And maybe I should write that equation down so you can see what's going on. For this example right here, the equation CH3 NH2 plus H2O liquid equilibrium. This is the base, so it's going to absorb an H plus, so it's CH3 NH3 plus OH minus. So when you do this X here, you're finding both the conjugate acid and the hydroxide. So if you were interested in that, the conjugate acid going the opposite direction, you would use Kw divided by Kb, 1 times 10 to the negative 14th divided by 6 times 10 to the negative 5th. Multiply that out, or divide that out, and then that way you'll get that. Now we're going to move on to the